second day of this training. Yesterday we started up by giving us introduction on the aspect of what statistics is all about. Then we equally mentioned the type of statistics that we have. Then we mentioned what variable, the various terminologies, then that we are going to be encountering in statistics. So today we're going to continue in that same vein. Then I also sent the software that we are going to be using. I send it across to us on the WhatsApp group. So I expect that latest by tomorrow we should have downloaded that software so that we can start interacting with the software itself, because that's actually the main purpose for this training. So today we're going to look at how do you choose the right statistics. Now you have data that have been given to you, that have been made available to you. Then how do you know the kind of statistics that you are going to actually
Is your network
use? Hello. Hello.
Okay.
Sorry, Mr. Ali, please can you mute so that your conversation won't be entering into the class? Hello. Please, can you hear me? All right. So, I was saying that today we are going to be looking at. Sorry, please, can you mute your mic, please? So, I said we're going to be looking at the various type of the different, how you choose the kind of statistic that you are going to use is what we are going to be looking at today. So for those that weren't in the class, yesterday's class, then do well to go through the the video, that is the YouTube link I sent, so that you will actually understand what we'll be talking about today. So now, basically, I'm going to share my slide now so that I will be able to follow suit. So just give me 1 minute to pull out the slides that we're going to be using. Okay. So can you see my screen now?
Yes, I can see it.
Okay. So today we are going to be looking at how do you get to choose how do you choose the kind of statistics that you're going to use to do your analysis. So that's what we are going to be looking at. Now, there are certain questions that you have to ask yourself when you want to engage in any kind of study. You need to understand what kind of study you want to do. So the first question is, what is your dependent or outcome variable? Yesterday during the class, I I took time to actually explain what dependent and independent variable is, because you will always be confronted with that challenge to determine what your uh, dependent and independent variable is. So you have to know what your dependent variable is. Then having know what your dependent variable is, then the next thing that you have to ask yourself is the outcome variable continuous? I also make mention of what continuous variable is. Then is it binary or categorical or time to event? Now, when we talk about dependent variable, because of peace, let me do. I think um, is quite straightforward. So when we talk about dependent variable, we have dependent and independent. When you say something is independent, it means that it's not dependent on something. But when you say something is dependent, it means that the effect of a particular variable affects affect that particular outcome. And I use the issue of malaria and risk factors to explain that to Mr. Ali yesterday. So the way I explained it was, now, assuming you took blood samples from patients, then we also subject those patients to questionnaire. You give them questionnaire to fill, and in those questionnaire there were certain questions that you were asking, and some of those questions were one that if there are stagnant water within the environment that such individuals stay, and secondly, that if the person do sleep under mosquito net. Now, I now pose a question to Mr. Lee yesterday, that between malaria status and the presence of stagnant water or sleeping under mosquito net, that which is dependent and which is independent variable. So, and Mr. Lee told me yesterday that the independent variable is the malaria status, because the dependent variable rather is the malaria status, because why the independent variable are those other variables or other factors that we listed, like the stagnant water, and also the sleeping under mosquito net, because sleeping under mosquito net and presence of stagnant water will most likely impart the malaria status of an individual. But the malaria status does not have any effect on the on either the stagnant or sleeping under mosquito net or stagnant water. So because the effect of sleeping under mosquito net or having stagnant water will on the directly impact on the malaria status of an individual, then we therefore say that the malaria status is dependent on those other factors, while those other factors are independent of the malaria status. So I hope that is clear. Now, the second one is talking about continuous variable. And I make mention that we have different types of variable. We said we have qualitative and we have quantitative. Then under qualitative, we have a binary or binary variable. Then we have nominal. Sorry, we have nominal and ordinal. So when we say something is nominal, we are saying that something that you name or that you use to group such individuals. They are also referred to as binary, something that is either present or absent, high, low, medium, and all the likes. And I make mention yesterday that, for example, for you to understand what we are saying, between what continuous variable and categorical or qualitative and quantitative variables are, I use the issue of malaria too as an example. Now, for some of us that are conversant with how malaria is scored, you know that someone either have malaria or do not have malaria. So that is binary. That is categorical. That is binary. Then also still there, you can move further by what we refer to as semi-quantitative. That's when you are talking about does this person, is it 1 plus, 2 plus, or 3 plus? So we are talking about the order now. We are talking about the scale. We are talking about the order. We are talking about the hierarchy of the magnitude, or yes, the magnitude of the malaria infection. That okay, this person have malaria, but it's 1 plus. This other person have malaria is 2 plus. This third person have malaria is 3 pluses. So those are still qualitative kind of variable. Then when we talk about quantitative, which is also referred to as continuous, we are talking about malaria test. Now, when we are talking about parasite density, because we are talking about numbers now, you can say we have 200 parasite per centimeter cube. So that is continuous. That is quantitative. So also I may mention of, for example, when you do a glucose test, for example, then the person can either be normal, low, or high, as the case may be. Then also you cannot try. Those are still categorical. When you are talking about is normal, is high, is low. But when you are not talking about the sugar or the fasting blood sugar of such individual is 5.6 milligram per DL. So you are no longer talking about just quality now, qualitative now. We are talking about quantitative because we are talking about the exact amount of glucose within that particular blood sample. So that is the next thing. Now, the next question that you ask yourself is, what is the unit of observation? What are you using to observe? Is it that is a person to person kind of determination? Is it a half a phase? We're talking about half a phase. We are talking about how do you actually determine this kind of what did you use to measure this observation? Was it a physician that determined it, or and all the other outcome? Then the next thing that you also have to look at is, are the observation dependent or correlated? When you say independent or correlated, so we are saying that this independent observation we are talking about now, when the observation is independent, we are talking about they are not related. They are not related to each other. But when we are talking about a correlated observation, we are talking about an observation that is that have relationship between one outcome and the other. Example is, for example, is when you are looking at a mother infant pair, when you are talking about husband and wife pair, when you are talking about sibling pairs, no, there is kind of correlation. There's a relationship between those pairs that you are doing observation. But when you are looking at male and female, for example, those observations are independent. They are not related. So that is one. Or you are talking about those from south, those from southeast, those from southwest, those from north central, northwest, and northeast, as the case may be. So those are independent. But when you are talking about things that are related, then you are talking about a correlated observation. Now, this is one way through which you usually determine the kind of statistic that you are going to use. Now, we are going to look at it, then we'll go further to, I will pull out another, I will then move further to explain more. Now, this table is actually showing us, this table is all you actually need to choose the kind of analysis that you are going to be doing for a particular study, as the case may be. Now, what I'm saying in essence is, you have a study, you have a population. Now, the next thing you ask yourself, this population that I have, is it a one sample population? Then the next question is it a two sample population, or is it a three or more sample population? Now, if it's a one sample population, then the next question you need to ask yourself is, the sample draw from a normal distribution? Tomorrow class, we are going to be looking at how to actually determine a normally distributed kind of data, because that's the next question that you will always be faced with. That having obtained this variable or this sample, then is the sample normally distributed? Because if the sample is normally distributed, there is a kind of analysis that you will be carrying out on that data. Then if this sample is not also normally distributed, there's also another type of statistic or statistical test that you are also going to use, as the case may be. So the first question you ask yourself is, what kind of sample is this? Is it a one sample? And if it's one sample, then the next question you ask yourself is, does this sample was this sample draw from a normal population? Then if it's yes, you can see here, if it's yes, then you'll be carrying out what we refer to as one sample t-test. But if it's not normally distributed, but it's a one sample population, then you'll be carrying out what we refer to as Wisconsin rank sum test. We are going to see how to carry out all these tests when we move to the software itself. So what we are saying in essence is, you must always ask that question. Now, you know that I said it is recommended to use a two-tail test unless you may have good reason to pick a one tail test. So that's just by the way. So what we are saying in essence is that in all your analysis, you must make sure that there are two tails, except if if conditions warrant you to use one sample, one tail test. So the next question is, if it's a two sample t-test, two sample population, the next thing you also ask yourself, are they drawn from normal population? Then if it's yes, then the next question is, are they peer sample? When we say peer sample, we are talking about, for example, you have one population, let's say males, but you take one sample at one from the same individual. Then after some time, you take another sample running the same analyte. Example of this is talking about your 2 hours postprandial test to determine diabetes, for example. You know, usually when the person come, you first and foremost take. Let's use this as an example. Let's assume you want to determine diabetes in a population of males, for example, in a particular particular location or geographical location. Then you book appointment with them. Then after the day that they were to come for the appointment, they came. Then in the morning, let's say they came around 9. Then from all of them, you collected fasting blood sugar from all of them. You collected blood sample from all of them to run fasting blood sugar. Then after you've collected that first sample, those same individual, then you ask them to go and take carbohydrate food, for example. Then after 2 hours, they return to you and you run, you collected another sample from them, then you run a glucose test on them too. So after that, then you, if you want to analyze that kind of result, having run and find out that they were normally distributed, because they are paired in sense that you take this sample from the same number of people and the same group of people twice. So that is paired. Then if it's peer T test, then you run what we refer to as peer T test. Now, if they are not paired, if they are not paired, then you run what we refer to as, but they have equal variance. Then you will run what we refer to as unpaired T test. But if they are equal variance, rather, you run what we refer to as unpaired T test. But if they are not, then you run what we refer to as wedge corrected unpaired T test. So you see all of that in the test. In what we're then, if they are not normally distributed, but they are paired, then you run what we refer to as viscosal match pair test. That is what we refer to as non-para. The one that usually run when they are not normally distributed is referred to as non-parametric test. We have parametric test and non-parametric test. So the non-parametric test are those tests that is run on a population that are not normally distributed, while parametric tests are those tests that you run for a study that is normally distributed. Then if they are not normally distributed and they are not paired, then you run what we refer to as Mann-Whitney test. Mann-Whitney test. Mann-Whitney test. So that's what you usually run most times on a whole lot of data that are not actually normally distributed. Then the next set of population is population that are 3 or more. So for these, you also ask the question, are they drawn from a normal distribution? If they are drawn from a normal distribution, then and they are paired, then you run what we refer to as repeated measured one way ANOVA. Repeated measured one way ANOVA. Then if they are not paired and they are normally distributed, you will run what is referred to as one way ANOVA. Then if they are not normally distributed, but they are paired, you run what we refer to as Freeman test. Then the next thing is, if they are not normally distributed and they are not paired, then run what we refer to as with Carley's, that is a Rokas Wallis test. Rokas Wallis test is what we usually run on that kind of study. So I'm going to stop here now and ask if there is any question at this moment so that I can take your question at this moment. Any question at this moment?
Sir, I have one, sir.
Okay, go on.
So if they are paired sample, can we say husband and wife? Can it also be a paired sample?
No, they are not paired. They are two individuals. They are not paired. Before you can say a sample is paired, those samples must be from one population that a particular test is run twice on them. Now, what I'm saying in essence is, let's say you have 200 students. Are you with me?
Yes, sir.
200 students. Then in these 200 students, you run glucose test on them. Then after maybe you now subject them to a particular kind of training. Let's say you teach them different kind of diet and all of that. Then after like 1 month or so, you call them back, those same 200 exact numbers. You now run another glucose on them, then you are now trying to check the differences between the mean of what you collected initially and the one that you are collecting, to know whether the intervention that you have given to them, if it worked. So I don't know if that is clear.
Yes, sir. It's very clear, sir. Thank you very
Okay.
much, sir.
So any question from others?
Yes, please. I have a question.
Okay, go on.
The normal distribution and not normally distributed,
Yes,
did I say phrase
a
or
sample.
thing?
Yes,
I actually don't understand
population.
it.
Okay, now when we say normally
What does it
distributed,
mean? I don't know what it is.
okay, for you to say, that's actually the topic we are going to be looking at tomorrow. So for you to say a sample is normally distributed, there are actually parameters that you are going to look at for. Those are some of the things we have to check tomorrow. You check whether they are skewed, if they are skewed to the right or skewed to the left, or they are not skewed. Those are terminology that we'll understand better tomorrow. So what I'm saying in essence is that when a sample or you generate a sample, but this sample I'm talking about continuous variable. I'm talking about some sample that are quantitative, not just present or absent, yes or no kind of data. I'm talking about a sample that is measured, that you measured, that you have number that are numeric in nature. So once you have those kind of data, the next thing that you are supposed to do before running any other thing on it is to actually run to check normality, is to check the normality of those data. Now, checking for normality is to make sure that those data meet the assumptions. There are some assumptions that every data must meet to determine the kind of statistical test that you are going to run on them. So if you have a population, if you have a sample that is not normally distributed, that is not that does not meet those assumptions, then it's not that you are going to throw those data away. There are things that you could do. One of the first thing that you do is to try to transform those data to make them to be normally distributed. Then if the transformation is not possible, then the next thing that you do is to use what we refer to as non-parametric test. So that's what we are going to be looking at. The truth is, majority of data are not usually normally distributed. So that's why most time you end up running non-parametric tests in majority of data. But in some cases, you could find data that are normally distributed. Then you go ahead, and that's why I don't know if any of you is doing your postgraduate at the moment. When you are presenting your data, your before your proposal presentation, that is the question they will always ask you. A question that how are you going to check for normality, and if it's not normally distributed, what are you going to do? So in this case, normality of a population, of a sample rather, is very, very essential before you determine the kind of test that you are going to be running on a numeric data. So I don't know if that's clear. I know it may look kind of complex to you now, but tomorrow, by the time we look at how to test for normality, then the understanding will be better for you.
Okay, since you
Please,
said we'll look at it tomorrow, I'll just wait
yes,
till tomorrow.
yes, because no matter what I try to explain now, if we don't, we need to look. Is in fact that is a whole lot of topic. Actually a very wide topic that we are going to be looking at tomorrow, because that's why you see majority of people will send out paper for publication. They will return it back to them and ask them to run further analysis on them, because the assumption of normality was not determined before the other statistics were run on such sample. So any more question? Okay, if there is not, so I'm going to reshare my slide, then we'll
I just
continue.
want to ask
Okay, okay,
if
go on.
we're going to get some of these
Some of what? Hello,
I just
peace.
wanted
I
to know
didn't
if we
get
have
that.
a PDF version. Yes, are we going to have a PDF version of
Oh
your
yes, of all
classes?
the PowerPoint. Yes, of course, of course,
Yes.
of
Okay.
course. So by tomorrow, I will send in the two classes we've had. So I will send the PDF PowerPoint to you guys so that you can go through.
Okay.
Then I
Thank you.
also want to please appeal that please let's download the SPSS software that the link that I dropped at the WhatsApp group, because that's actually what we are going to be using from tomorrow. It's very, very essential because these are just the theoretical aspect that any of us could pick up. Yes, in as much we need guidance, we can pick up book and read on them. But it's tomorrow we are going to be looking at the practical aspect. So I want to appeal. I think it's about 300 MB or so. So just download it, then try to install. If you are not able to install, then I will. It's a very straightforward installation. Just usually click, then it will install. Then tomorrow we'll also look at how to the interface of the software itself. Then we'll start uh, the, the use of the software from the normality class tomorrow. Exactly. So I'm going to share my slide now.
Hello, good evening.
Yeah, good evening, sir.
Good evening. This is Michael. I'm
Okay.
sorry I couldn't join yesterday. In fact,
No
I've been
problem.
scheduled for this class for more than, I think, close to 5 months now, if not up to. Yesterday, I closed very late from work. So before I could, it was already past, I think if it's not past 8, I think around to 9 or so. So I couldn't join yesterday. Even today, I just joined not quite long. I'm sure you saw when I joined.
Yeah.
Yes, so it has not really been easy for me. I work in a very busy facility where our closing time is 5 o'clock, but I don't actually close by 5. So
Okay.
it's been very tedious, and that's why I've missed the previous classes. And they kept shifting me to the following month, but I didn't even know exactly when this today one started.
It's actually 8. I posted it on the group. That will start by 8.
Okay,
So usually the
okay.
reason why we actually make it 8 because of some of us that
Uh,
have to go to work. I know most of us may not be back home till around 7 or so, or even sometimes 8, especially
you're quite
for those of us or some of you guys that stay in Lagos can know how Lagos
that's,
traffic can be. So
that's true. You're right.
those are some of
You're right.
the consideration
You're
that
right.
we
Actually, the
try.
little class I met was actually quite beneficial, but I think I will still appreciate the soft wares
Of
or
course,
the what's it called? The slides you
the
said you're going to
PowerPoint, of
send to
course, of
us
course. I will
so
once
that
I finish the class now, I'll share the
okay,
slide on the group so that you can download.
okay,
Then also do your
okay,
further. Then I also share. I think I don't know if I share. I also share a textbook
okay,
on statistics with you guys on the
okay,
group so that
okay,
just
okay.
you
I
keep
appreciate that.
reading. The truth is, like I usually tell all my students, um,
Okay,
your success in this particular endeavor is not just on this class. This class is just to give you a head on or to know
yeah, that's
what next to do because uh,
true.
statistics even me that I'm teaching you I'm still learning. I keep learning more
Mm,
softwares, keep learning more
mm,
things. So
mm.
uh just this was how I started. Someone just taught me, then I
Wow,
pick interest on it, then I keep developing myself, paying for
wow,
classes, reading, watching YouTube videos,
wow.
attending seminars and all of that. So which I also believe that you can do. And let me be sincere with you. Sorry to actually, this class is not just about to come here and teach you. but it will also
That's
show
true.
you the business aspect of this.
Okay.
The what I've been able to get by the grace of God is God and this skill that I have acquired.
Hmm.
My first job, I happened to did my I did sorry to I'm going to bore you a bit so
You're
that
trying to
you
digress, but it's
understand the
good actually.
importance
No, it's
Yes,
of
it's
welcome. We
this
good.
want to
of
make
this
money
class.
as
It's good.
well. So
Sir, we
fine.
So
need it. We need it.
what I'm saying in essence is this. When I did my internship, I'm also a medical lab scientist. I did my internship in National Hospital. So how do I start this biostatistic as a side hustle that I've even, in fact, I even earn more, to be sincere, on this than my regular job. I lecture at the university, but I earn more on this than what I get as a salary. Yeah, it may
Hmm.
not come every time, but
Yeah, that's true.
you are, yes. Now, back to the story I was telling you guys. I did my internship in National Hospital. Then, how I started it, it was when I wanted to do my final year project, my BMLS project, that I met a colleague then. So he just told me certain things then, and I didn't actually want to give my work to anybody. Yeah, there were guys then that you give, they will help you to run the analysis, then that will be all. But that was not, I didn't really want that. So what I did was I met a colleague, a senior colleague then, who did his work that I was really that was interesting to me. So he just gave me a CD on the chi-square then. So I went ahead, do some research on chi-square. That was when this phone then was not really very available. That was 2012. So I just did, I was using this small phone then. So I just start browsing about it, about chi-square and all of that. So I did my statistic myself, and by the grace of God, it skate through the process. Then after then, because of how I was able to do it very well, other students were now coming. My junior colleague now started coming to me to help them to do theirs. Then I now finished. Then I went for internship at National Hospital. So I was
Hmm.
just usually during interaction, there is this, these our friends, our doctor friends. So they were just discussing that they are planning for their part two fellowship, that they don't know how they are going to run their statistics. And sincerely, then I was not yet an expert. So I just
Hmm.
heard them talking about it. So and I said, is it not statistics? I can help you to do it now. So one of them just said, okay, let's see what you can do. He actually gave me his data. Then I took time now start researching. At least internet was now a bit accessible. Then I did a whole lot of research. I watched YouTube videos, did a whole lot of reading. Then I did his own. And guess how much he paid me? 5,000 naira. I was still happy. Then after I did his own, then he now introduced me to one of his friends.
Hmm.
Do you know that he paid me 5,000 naira? I'm talking about 2014. Then the
Hmm.
person he introduced me to paid me 70,000 naira.
Imagine.
So after then, I'm not
It's,
bragging.
it's
Almost
going.
all the work in National Hospital, all their fellowship, PhD work, master's work, fellowship work, I'm the one doing it. I'm no
Hmm.
longer in Abuja, but they will send their work to me via mail, send their proposal. Then I just review them and run the work. I send
Statistical
them their
analysis.
data. If there is any correction, then I do it. So what I'm saying, and when I went to serve it, what did I do? I met another person that I saw it was very good. Then I paid him. He was always coming to my house every Sunday to come and teach me. Because he actually did demographic and statistics. So he was a guru. So he taught me all the things I need to know about statistics. Then I'm not also exaggerating. By the grace of God, I even know it more than him now. So
Hmm.
that's what I want to encourage you. You guys can actually pick what I'm teaching now, then develop more on it, and even know it more than myself. So it's not like the knowledge is not hidden. It's available
That's true.
everywhere, online, everywhere you will find it. So, but the only thing is you need a foundation, and it's that foundation that I'm actually here to give you guys, because the truth is, if you do not have the foundation, when you pick up data, it will look like one. Even there are some terminology you will just be hearing, you will just be telling yourself, what is all of this story, that all of this. So you will just feel, you just throw it and leave. So that's just a bit of it. And it's not only there, even there's a whole lot of work that are available as a freelancer online. There's this platform called Upwork, this Fiber and all of that. So if you have time, when you really develop yourself to an extent, you can go there, sign up, even when you are doing your normal 8 to 5 kind of work. When you come back, you have a client. I know people that are making $1,000 monthly from just doing people's data online. So it's something that you can actually explore. But the truth is that it does not just stop with what I'm going to teach you guys. You, after
Yeah.
learning this SPSS, you have to learn other. For example, now I'm presently learning uh, um, coding software, because there's an extent you get to, you have to also learn a bit of coding. You learn either Python or R and all of that. So that is the stage that even myself are also in now. So I want to encourage you. It's a very good and lucrative aspect of a profession that a lot of people is now that a lot of people are actually venturing into that
Exactly.
area.
You're right.
Yes.
You're
So
very correct.
I want to encourage us. So I don't know, Peace just went off. I probably, maybe she had a call. So I'm going to share my screen again, then we'll continue from that area.
Okay. Thank you.
Thank you very much, sir.
Yeah, thank you. So, no, yeah, I think, okay, we are through with this. Now, this is actually an extension of what uh, the previous slide, but this is more
Okay.
comprehensive. Uh, Now, this is an example of what can be possible. Now, you see, this is the outcome variable, and we said outcome variable are usually dependent variable. So now, this outcome variable can be continuous. Now, if it's a continuous variable, example of continuous variable could be your blood pressure, your age, pain score, IQ score, and all the kind of score, blood glucose, cholesterol, malaria, parasite density, bacteria counts, and all of that, microbial count, and all of that. So those are continuous. Now, if they are continuous, the next question you ask yourself is, are they independent? Now, if they are independent, meaning that if they are not related to each other, then you can run either a t-test and an over a linear correlation or linear regression on it. But if they are correlated, then what you are going to be running is either a peer t-test, a repeated measured ANOVA, or a mixed model GEE modeling. Then the assumption here is that outcome is normally distributed. That's the, I mentioned of assumptions. There are assumptions for you to run all these things that we are talking about. They have to be normally distributed. Is also saying that important for small samples, then outcome and predictor have a linear relationship. So for you to run, for example, we are talking about regression, there have to be a linear relationship between the outcome and the predictor. Now, the next thing is if it's a binary, if it's a binary, sorry, if it's a binary or categorical variable. Now, when we say categorical, we are talking about, for example, if there is a breast cancer, a yes or no, malaria is a yes or no, a male or a female kind of outcome too. Then if it's that, then the next thing that you need to look, you'll be talking about a chi-square. Now,
If it's an
it could also
independent.
be, yes, relative risks. That's the kind of analysis that you'll be talking about when you're talking about binary or categorical kind of data. It could be a chi-square test. It could be a relative risk test. Then it could also be a logistic regression. Then if they are independent, but if they are correlated, then we are talking about Mark-Newman test or a conditional logistic regression, or it could also be a GEE modeling. Now, for you to be able to run all these things we are talking about, they have to be sufficient number in each cells. We are going to see this when we go into the practical session. Now, what we are saying is that usually, for example, a yes or a no. So if a yes is less than, if it is less than 5, then you cannot run a chi-square on it. You'll be running what we refer to as Fisher exact test. So we cannot run a chi-square for a sample that is less than 5 in a particular box. When we're talking about box now, in neither a yes or a no category. Then the next one is a time to event. We are talking about a time to death. We're talking about a time to fracture. So in this kind of test, if it's independent, then we'll be talking about a Kaplan-Meier statistic. This is actually when we are talking about survivor analysis. Then we are talking about the cause regression. Then we're also talking about survivor analysis. Then we'll see all of that. Now, the assumption here is that cost regression assume proportional hazard between two groups. So there have to be measure of hazard for you to run this cost regression on any kind of data. Now, the next thing that we want to look at, this is the continuation. This is an expansion of this first. This is an expansion of this first aspect now. Now, we are saying that now for a continuum variable, for you to run t-test, we are talking about comparing means between two independent groups. For example, checking the cholesterol level between male and female. Now, because male are independent of female, then you'll be running what we refer to as t-test on them. But you know that for you to run a t-test, it has to be comparing two independence group, and those two groups must have normally distributed outcomes. Now, if they are not, if they are paired, now we are saying that comparing mean between two related group, e.g., the same subject between and after. Just like I said, running glucose, taking glucose level of let's say 10 individual, you take their fasting blood sugar, then after 2 hours you take another sample again. Now you take an after before meal and after meal for the same group. So in this kind of data, then you'll be running what we refer to as paired t-test. Now, if they are not normally distributed, these two that are mentioned, they are actually what we refer to as parametric statistics. Now, if they are not parametric statistics, then we'll be talking about with Cousin sign ring rank test. This is for a non-parametric test. This is actually an assumption, an alternative to the paired t-test. So if for alternative to t-test is actually the man unit, that is the man Whitney test is what you usually use in place of t-test for non-parametric test. Now, if it's ANOVA, we are comparing mean between more than two independent groups. Then, if it's still more than two groups, but in this case, we are checking for more than two groups, but in this case, we are checking over time. Let's say you take before meal, 2 hours after meal, then 3 hours after meal. But you know, in this case now, we are looking at three variables from the same population. Then we'll be doing what we refer to as repeated measured ANOVA. Then for Pearman correlation coefficient, then we are talking about linear correlation. So for this, you'll be checking the correlation between two continuous variables. So it means that you cannot run you cannot run correlation on categorical variables. So for you to run correlation, they must have to be for you to run correlation on any variable, the two arm of variable have to be continuous. So you can check correlation between age, for example, and cholesterol. You can check between age or between let's say an average coefficient IQ test and quality of life score and all of that. So it has to be a continuous variable that you have to test correlation on. Then the next one is linear regression. So now for linear regression, we are talking about multiple regression technique. For this case, you will actually be comparing continuous when you are actually looking at outcome that is continuous, giving slope or adjusted mean. But in this case, we are talking about trying to check a kind of more than one, when you are checking kind of a relationship between more than two continuous variable. In this case, you want to check the relationship between age, quality of life, and IQ test, for example. So for those three, you'll be using what we refer to as multiple regression. So in place of ANOVA, for non-parametric tests, you'll be doing what we refer to as Whisker Waris test for non-parametric alternative to ANOVA. While PMR rank correlation is usually the alternative to Pearson correlation for parametric test in place of non-parametric test. So like I mentioned yesterday, there are a whole lot of technologies that are available for you to use as a statistician. Now, some of those softwares, we have the SPSS and the Excel, we have the Arrow, we have the Python, we have the Minitab, we have the Stat, the Stata, then we have the SAS, and a whole lot of other softwares that are available for analysis. So we will I will stop sharing now, then I'll take your questions, then we'll share, we'll call it a day for today, then we'll continue tomorrow. So any question from those other aspects that I have shown?
Well, maybe as the lectures progresses,
yes, sir,
tomorrow a better question. But I think for now, well,
okay.
Some few are quite clear, many are not clear. But I know as we progress, definitely we'll begin to get things right.
when we start, when we start the
material
practical aspect of the practical, then we start looking at data, practical data, real life data. Then all these big grammar will be broken down.
Okay.
Yes.
Good. No problem. I think I'm okay. For me, I'm okay.
Ali, Mr. Ali, any question from your end?
I just want to confirm something, sir. The examples the tests we just saw, the t-test, the ANOVA, the Spearman correlation, and everything we just checked out. Did they all deal on continuous? Did they all deal on continuous outcome, or what's it called? The other one can also be there.
Categorical. Yeah, for
discrete. Sorry.
Yeah.
Discrete.
No, discrete. Yeah, discrete could be quantitative. So generally, quantitative variable work for either continuous or discrete variable work for those work for any of those statistics I mentioned. But when you are dealing with categorical, then we'll be dealing with chi-square, we'll be dealing with logistic regression, binary regression, and all the likes. But for for quantitative variable, any of those what's it called? Any of those
Test.
statistical tests I mentioned will work, whether discrete or continuous.
Okay. All right, sir. I think I'm clear for now, sir. Thank you very much, sir.
All right. If there is no more question, then we'll call it a day. Then tomorrow, again, same time by 8, then we'll reconvene again. Then I want to appeal again. Let's try and download the software and install on our laptops so that tomorrow we'll be able to. You can still join with your phones, but you have to have a laptop to demonstrate whatever I'm doing. Or better still, it will actually be better if you are using your laptop to join. That would, because at a point I may want you to share your screen to show me what you are doing to be sure of what you are doing too. So I want to thank you for joining in and see you guys tomorrow.
Thank you
All
very
right.
much, sir. It was a beautiful class, sir. Thank you, sir.
Thank
Thank you very